Hi class, today is lesson 5-1 on the least common multiple. Let's go ahead and write down our purpose. Our purpose is to find the least common multiple of a group of numbers. Let's go ahead and turn to the back of our books and write down the term least common multiple and its definition. The definition of least common multiple is the smallest number that is a multiple of two or more numbers. Let me go ahead and illustrate this through a word problem. So stay on this page that you've just written the definition on, and you're just going to write down how we execute the problem. Please don't write down the actual word problem, but just how we execute it. Here it says juice comes in packs of 6 and granola bars in packs of 8. So if there are 24 players, what's the least number of packs needed so that each player has a drink and granola bar and there are none left over? So we're looking for a multiple of both 6 and 8 that is common to both and is the smallest multiple possible. Let's go ahead and take the biggest number, and this is going to be a hint later on down the road for you as well. We're going to take the 8. There are 8 granola bars in that pack. And then we're going to take the 6 juices in a pack. And we're going to continue with the largest number, the 8, and see if the smaller number is a factor of the bigger. For example, we're going to take another pack here. And we've got a total of 16 granola bars. Does 6 go into 16 evenly? No. Does 6 go into now 24? There are 24 crackers. Does 6 go into 24 evenly? And yes, it does. So how many packs of juice boxes do we need in order to get 24? Well, we need 4 total. So here we go. We've got 4 different packs, which equals 24. And here we've got 3 packs of granola bars, which also equals 24. 24 represents the least common multiple of 6 and 8. Now we can do this without drawing groups. First method we're going to look at is the list method. We're going to take 3, 5, and 6 and find the least common multiple. How do we do that? We're going to write down 3, 5, and 6, and then we're going to start with the biggest number. Okay? Let's go ahead and find the multiples of 6. Well, 6 is the first multiple of 6. Does 3 or 5 go into it? 3 does, but 5 does not. The next multiple is 12. Again, 3 goes into it, but 5 does not. The next multiple is 18. 3 goes into it, 5 does not. The next multiple is 24. Does 3 go into 24? Yes, but 5 does not. The next multiple is 30. Does 5 go into 30 at this point? Yes. Does 3 go into 30? Yes. So we've actually found the least common multiple. And we're going to go ahead and head back to each of these other factors and find the multiples. 5, 10, 15, 20, 25, and 30. And for 3, we're going to do 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30, just to prove the point that yes, this is the first multiple that we come across for all 3 numbers, the least common multiple. So now we write down least common multiple equals 30. So that's the list method, where we list the numbers out. In the next example, we're going to go ahead and use prime factorization. First of all, I'm going to take the 8 and the 12, and I'm going to make prime factor trees. 2 times 4, That's 2 times 2. So that is 2 to the third power. Now 12 is 2 times 6, which is 2 times 3. And those are prime factors as well. So we have 2 squared times 3. Now we've done the first part. First step is to find the prime factorization of each number. Then we're going to go ahead and write down the prime numbers represented. Well, there's a 2 represented here, and there's a 3 represented here. And essentially, that is all the prime numbers that are represented between the two. Our next step is to choose the largest power of each prime. Well, for the 2's, it's between a power of 3 or a power of 2, and we're going to choose the power of 3 because it's the largest. With the 3, there is no power, or the power is actually 1, so we're just going to leave it as a 1. Now, when we are past this point, we've chosen the largest power of each prime, then we simply multiply. 2 to the third we know is already 8. So, right, 8 times 3 is 24. So the least common multiple for both these numbers, the first multiple that you come across for 8 and 12 is 24. That simple. Now we're going to go ahead and do the same for 12, 10, and 15. First thing we do is find the factors. So I have 12, 10, and 15. 12 we know, we did it 2 times 6, and then it's 2 and 3. Those are all prime numbers, so that's 2 squared times 3. For 10, it's 2 times 5, and those are prime numbers. Bring those down. And for 15, it's 3 times 5. And those are prime numbers as well. Now, we found the prime factorization. Now we write the prime numbers represented. Well, there's a 2, there's a 3, and there's a 5. Note that the 2 is not common to all numbers, and the 5 is not common to all numbers, nor is the 3 common to all numbers, but these are all the primes that are represented. Now we choose the largest power. For the 2, it's 2 squared. For the 3, it's just 3 to the first power, and for the 5, it's 5 to the first power. So now we've found the largest power of each prime. Now we're going to multiply these. This is 4. 2 squared is 4. 4 times 3 is 12, times 5 is 60. So the least common multiple here is 60. Pretty simple, huh? Then we go to your responsibility. Your responsibility is to find the least common multiple, of course, and to complete the problem. I've given you the same problem in both cases, 4, 12, and 15, 4, 12, and 15. But you're going to use a list first and then prime factorization for the second. So remember the list. You write down 4, 12, and 15, and you go ahead and start with the largest number, which is the 15, and find the factors of it. With prime factorization, of course, over on this end, you're going to start with the trees and then take those 4 steps that we used in the previous problem in order to get your answer. And you should come out with the same answer on both sides for least common multiple. All right, we'll see you in class.